Example 11, for what values of r is the sequence open bracket r to the power n close bracket convergent? Solution: we know from section 2.6 and the graphs of the exponential functions in section 1.4 that the limit as x approaches infinity of a to the power x equals infinity for a greater than 1, and the limit as x approaches infinity of a to the power x equals 0 for where a is greater than 0 but less than 1. Therefore, putting a equals r and using theorem 3, we have the limit of n r to the power n as n approaches infinity equals open bracket infinity if r is greater than 1, 0 if r is less than 1 but greater than 0. It is obvious that the limit of 1 to the power n as n approaches infinity equals 1, and the limit of 0 to the power n as n approaches infinity equals 0. If negative 1, if r is greater than negative 1 but less than 0, then the absolute value of r is greater than 0 and less than 1. So the limit of the absolute value of r to the power n as n approaches infinity equals the limit of the absolute value of r to the power n as n approaches infinity equals 0. And therefore, the limit as n approaches infinity of r to the power n equals 0 by theorem 6. If r is less than or equal to negative 1, then open bracket r to the power n close bracket diverges as in example 7. Figure 11 shows the graphs for various values of r. The case r equals negative 1 is shown in figure 8. Figure 11, the sequence a sub n equals r to the power n. The results of example 11 are summarized for future use as follows. 9, the sequence open bracket r to the power n close bracket is convergent if r is less than or equal to 1 but greater than or greater than negative 1, and divergent for all other values of r. The limit the limit of r to the power n as n approaches infinity equals open bracket 0 if negative 1, if r is greater than negative 1 and less than 1, and 1 if r equals 1. Definition 10. A sequence open bracket a sub n close bracket is called increasing if a sub n is less than a sub n plus 1 for all n greater than or equal to 1. That is, a sub 1 is less than a sub 2, which is less than a sub 3, which is less than, and so forth. It is called decreasing if a sub n is greater than a sub n plus 1 for all n greater than or equal to 1. A sequence is monotonic if it is either increasing or decreasing.